All right, so day one says solve this system of equations. There's no graph here, so we're not going to graph it. There is no variable by itself, so I'm going to do this by way of elimination. You could either try to eliminate your x's or your y's. Which one did you try to eliminate? X, okay. So if this is 8x, what would I force and make this x down here? I need to make it a negative 8x, right? Which means I need to multiply everything in this equation by negative 8. Okay? Everything times negative 8. So I get negative 8 times x is negative 8x. Negative 8 times 2y is minus 16y. And negative 8 times negative 12 is going to be a positive 96. I'm going to put a single line through that because I know I am adding these two together. Can you see? No. Do you want to move here? Is that a little better? So here are my opposites, and I like to put a rectangle around those, saying I know I'm eliminating those. Adding those together, 8x and negative 8x is 0, okay? And I can put 0 down here, but I don't have to. Then negative 3y plus negative 16y is a negative 19y. And a negative 1 plus 96 gives me a positive 95. And you're like, ooh, that's a really big number, right? But don't worry. Just follow the process. This is negative 19 times y. This is 0 minus this, which 0 is just going to pretty much cancel out. So divide it by negative 19. Divide by negative 19. Negative 19 simplifies out, and y is equal to... Did anybody actually check this out on a calculator? Yeah, it's negative 5. It actually goes in there evenly negative 5 times. So that's your first variable. What do I need to do now? Am I done? That's right. You need to substitute this in. And my second equation has this x by itself. So I'm going to use my second one and say x plus 2y equals negative 12. So x is what I'm searching for, plus 2 times my y value of negative 5 is going to equal negative 12. So x plus 2 times negative 5 is minus 10, or a negative 10, equals negative 12. Add 10, add 10. 10s cancel out, and x is equal to negative 2. So what does this mean? This means that these two equations are what kind of lines? Intersecting lines that have a single point where they intersect as its solution. So the answer here in solving this system of equations is negative 2, negative 5. You did the y's, but you get the same answer, right? Good. Excellent. And that's fine. There are many ways to do math problems. Okay? Any questions on that problem? Yes. Oh, you're done? Just go ahead and put it in the green bin. All right, number 2. Solve the system of equations. Well, we got 2x plus y equals 8. We got 3x plus 3 halves y equals 12. What do you want to try here? Okay. You want to try to eliminate the x's? Okay. We can do that. What would be my least common multiple? of 2 and 3? 6. So I'm going to take the top one to 6x, okay? I'm going to make this a 6 up here. Let me get rid of this. And I'm going to make this bottom one, what's the bottom one going to have to be? Yeah, -6, right? Because we are trying to get rid of my x's. So that means I need to multiply this first equation by what amount? Class? The top one I'm going to do times +3. No. So let's just do that one. So 3 times 2x gives me 6x. 3 times y gives me 3y. And 3 times 8 gives me 24. Okay? Now, if I want -6x on the bottom here, what am I going to have to multiply this bottom equation by? -2. Because -2 times 3x is -6x. -2 times 3/2 y. This gets a little tricky. Put that as a 2/1. The 2's are going to simplify out, okay? And I'm left with negative times 3y, which is -3y. And even though the 2's canceled out here, I still have to multiply 12 by -2 to get -24. Everybody see how I did that? You're just multiplying -2 times each term in that equation. All right, now we're going to add these together. So I have a 6x plus a -6x. That's what we were trying to get rid of initially, right? And that's my 0. That zeroes out. 3y plus -3y. What does that give me? That cancels out too, right? So that's a 0 equals 24 plus -24. Well, those are two opposites. When you add them together, you get 0. 0 equals 0. Well, first of all, is that true? Does 0 equal 0? Yes. So what does that mean for this system of equations? Is this a pair of intersecting lines? No, it's not no solution. If it was no solution, it would be like 3 is equal to 6. That would be that. No, they're not parallel. That would be no solution, which it's not. So if I say 0 equals 0, this is true. And this means I have infinite number of solutions. Okay? Infinite number of solutions. So this is where you have one line lying on top of the other. Okay? One line lying on top of the other. So then I had a student ask, well, you know, what are some of the solutions on there? And I said, that's a good question. Because this tells me there are infinitely many, but we don't know what any of the solutions are. So what could we do? We actually substituted a value in. So let's say I said x was equal to 0. You don't have to write this down, but if you want to, you can. If x equals 0, then I have 2x plus y equals 8. 2 times 0 plus y equals 8. 0 plus y equals 8. That's going to be canceling out, so y is equal to 8. So the point 0, 8 would fit for both of those, okay? And then I just picked another number, 1. What if x was equal to 1? So then 2x plus y equals 8. 2 times 1 plus y equals 8. 2 plus some number equals 8. Well, we all know what that number is going to be. Y is equal to 6. So that would be 1, 6. So you could pick pretty much any point, substitute it in, and it's going to have a solution that goes with it. Okay? You just would have to put it in. But this tells you there are infinitely number of solutions. Okay? Any questions on that? So remember, if you come up with a statement that is true, that's infinite number of solutions. If you come up with a statement that is false, like 3 is equal to 6, that is no solution or the null set. Okay? That's the difference. All right. Let's go now to page 1. Let's talk about multiplication of exponents. Page 2, thank you. Page 2. Now, we have talked about exponents before. We've talked about them mostly in order of operations. Now we are going to be multiplying them. Okay? So on page 2, module 10.1, multiplication properties of exponents. This is called the product of powers. Product. What does the word product mean? What kind of operation am I talking about when I say the product? Yeah. It's actually the answer to a multiplication problem. The answer to multiplication. So we are multiplying. If they say find the product of 5 and 3, that means 5 times 3, the product would be 15. So a monomial has that prefix of mono. What does mono mean? Does anybody know what that means? 1. Yes, very good. A monomial is a number, a variable, or a product of a number and one or more variables. It has only one term. Okay? The term a to the 4th is a monomial. An expression that involves division by a variable is not a monomial. So if you have division in it, it's not a monomial. So a times b divided by c, not a monomial. Not a monomial. Key concept, the product of powers. To multiply two powers that have the same base. They have to have the same base. So I want you to underline same base. You are going to add the exponents. Encircle that. Add the exponents. Okay? So, for any real numbers a and any integers m and p, a to the m power times a to the p power is equal to a, you keep the base, and you add the exponents. And then it gives you an example. B to the 2nd times b to the 4th is b to the 2 plus 4 or b to the 6th. A, or is that a D? Maybe that's a D. D to the 3rd times D to the 7th is D to the 3 plus 7, which is D to the 10th. Put that away, please. So what does this mean? If I have b squared, what does that mean if I were to write it out? B squared. What does that mean? What is that telling me to do? Multiply b by itself how many times? 2 times. So that b squared is b times b, right? And this dot says times, so we're multiplying again, b to the 4th, which means I'm multiplying b times itself 4 times, right? So 1, 2, 3, 4. Now, if I didn't know this rule, I would say this is multiplying b times itself how many times? 6 6 times, right? So this would be b to the 6th power. But instead of having to write this out each time, if we keep this in power form, you keep the base, b, to the 2nd power, and you add the exponents. Times b to the 4th is b to the 2 plus 4, which is b to the 6th. So this is what it means written out, but so we don't have to write it out each time. This is kind of like a shortcut, okay? But this is why it works. Any questions on that? All right, so let's go to some examples here. 3n to the 4th times 4n to the 7th. These numbers out front are called coefficients, okay? We can multiply those together. So I'm going to pull my coefficients out front and say 3 times 4, all right? Then I'm going to group together my powers that have the same base. So I'm going to say times n to the 4th times n to the 7th, okay? I can multiply 3 times 4 and get 12. And I can multiply these powers that have the same base. N to the 4th times n to the 7th is n to the 4 plus 7. And then putting it all together, 12 times n to the 4 plus 7 is n to the 11th. That is your simplified expression. So instead of me writing out n times n times n times n, and then multiplying n times n times n 7 times, I don't have to do that. We just keep the same base and add the exponents. Isn't that nice? Yeah, it is. All right, let's take a look at b. Look at your coefficients. Those are the numbers out front. So 7 times 2. Then I'm going to put together my x's times x. Uh-oh. What is my exponent on that first variable of x? There's nothing there. If there is nothing there, you're going to be like Beyonce. And instead of putting a ring on it, you're going to put a 1 on it. Put a 1 on it. So that is x to the 1st times x to the 4th. And then I have y to the 2nd times y to the 3rd. So 7 times 2, I know that's 14. X to the 1st times x to the 4th. If you have the same base, and I like to do this at the beginning, underline the same bases so it's very visually obvious to you. You keep the base and you add the exponents. Y to the 2nd times y to the 3rd. And we're multiplying here. Keep the base, add the exponents. So my final answer is 14, x to the 5th, y to the 5th. And since that is the answer, this is called a product. All of these things have been multiplied together. Excuse me. But that is my simplified product for multiplying these two expressions together. What questions do you have about that? Well, it can be if you understand it. All right, so let's take a look at the next example. 7n to the 7th times negative 7n. See if you can do that one on your own. Kayla, put that away. Do this next one on your own.
I don't know if I
you got a positive times a negative is going to give you a, yep. And then it's correct. Again, with math, you have to be so very careful with your signs. So take a look up at the front. Check my work with your work. So that is 7 times -7. And n to the 7th times n to the 1st. Put a 1 on it. Oh. Yeah. You're going to hear that song a lot. You're like, oh, great. N to the 7th times n to the 1st. They have the same base. You keep the base. Add the exponents. Which gives me -49 times n to the 8th power. How many had that for an answer? Yes, and the crowd goes wild. If you didn't, do you understand what you did wrong? Okay. All right, let's go to the next one. Look and match your coefficients up front. So I got 4 times -2. I've got a to the 2nd times a, put a 1 on it. Oh. I've got b with no exponent, put a 1 on it. Oh. Times b to the 5th. And then I have c to the 3rd times c, no exponent, put a 1 on it. All right. 4 times -2 is -8. A, they have the same base. Add the exponents. 2 plus 1. B, they have the same. Oh, I said same exponent. They have the same base. I think I said exponent. They have the same base. Add the exponents. C, same base. Add the exponents. So final answer, -8. A to the 3rd power. B to the 6th power. C to the 4th power. That is your final answer. Questions about that? All right. Let's see if you can do this next one on your own. 11, x to the 6th, y to the 6th, times x, y to the 9th. Everybody do that on your own. Check your answer with mine at the front. Now, some of you might not have had that 11 times 1. That's fine. That's kind of a 1 understood. Okay? It would be right here. Don't have to have that. And then you've got your like bases, x to the 6th times x. Put a 1 on it. You add those exponents together. 6 plus 1 gives you the 7. And then the y's. y to the 6th times y to the 9th. They have the same base. So you add the exponents. Any questions about that? How many got that for the answer?
So whenever it doesn't have a base, you just put a 1.
When it doesn't have a base,
So like you see the parentheses, so it's a base, but the other one you don't have a base, you just put a 1.
like this one right here, is that what you're talking about?
Yeah.
As a coefficient, yes. It's not called a base, but it's coefficient. But you don't have to. I mean, it is one understood, but you can put it there. All right, last one on this page. So we have -5. I'm going to do this down just a little. So -5 times 6. Those are my coefficients. Numbers out front. Then I've got an h, no exponent, so put a 1 on it. Times this h. Ooh, another one without an exponent. Put a 1 on it. Then I have j to the 2nd. Oh, that second term does not have a j. That's okay. So it just stays by itself. And then the last one, I have k to the 2nd times k to the 3rd. So -5 times 6 is -30. I have 2 powers with the same base, and we are multiplying them. So you keep the base, add the exponents. J, that's the only j there. You just keep it as j to the 2nd power. And k, you keep the base. When you're multiplying powers, this is when you're multiplying powers, you keep the base, add the exponents. So my final answer is -30, h to the 2nd, j to the 2nd, and k to the 5th. Any questions about that? No, not really. You could start it, but... All right, let's go to the top of the next page. Scientific notation. How many of you have had that either in math classes before or maybe science classes? No? Science a little bit? Okay. So scientific notation refers to expressing a number as a product. What did we say product meant? Multiplication answer. So we are going to be multiplying still. The product of any number between 1 and 10. Between 1 and 10. To the 10th power. Scientific notation is mostly used when dealing with large quantities of numbers containing many digits, since it shortens the notation. So it could be very large numbers or it could be very small numbers also. Very small numbers. Okay? So to write a number in scientific notation, if it is in decimal form, so this one, the first one here is in decimal form, okay? Move the decimal point to the right of its original position, so it's placed between the first, or it's placed after the first non-zero digit. So as I'm looking at this whole number, I want to put it so I have a number between 1 and 10. So that is 6.43, okay? The exponent of 10 will be the number of places the original decimal point was moved. And it is here, I look at it differently. To get from this back to the original, I had to go 1, 2, 3, 4, 5 places to the left. So that makes it negative. Okay? So 6.43 times 10 to the -5th. If the number is to be changed to scientific notation, and is a whole number greater than 10, move the decimal point to the left of its original position, place it after the first digit. So again, the key here is we want a number between 1 and 10. Well, 125,000, I have to put it after the first number. Okay, so that's 1.25. Now, where is my original decimal point? It's right here at the end. You don't see it, but that's where it is. And to get from 1.25, I need to go 1, 2, 3, 4, 5 places to the right. Okay? So you look at your number, place, and you don't have to write this, place your decimal point after the first digit larger than 0. And then multiply by power of 10 and if you go to the right, count the spaces, and it will be like 10 to a positive number. And if you go to the left, you count the spaces, and it will be times 10 to a negative amount. Okay? Erica, let's put that away, please. All right, so let's see if we can do a couple of these together, okay? This is what we call standard form or decimal form, as they said up above. This is decimal form. This is a very small number, okay? I want to put it in scientific form, scientific notation. I am going to write it down and put my decimal point right here. Okay, between or right after the first number. So this now becomes 5.9. I don't need to do anything with all those zeros. Times 10. Now, what did I have to do to get from 5.9 to this number? I had to go, and you go from this number right here, 5.9. 1, 2, 3, 4, 5, 6 places to the left. So that is going to be times 10 to the negative 6 power. So wherever you put your decimal point here, count, are you going to the left? That's going to be negative. Or are you going to the right? And that's going to be positive. So let's take a look at the second one, 120,000. I need to put my decimal point after the first number that is not a 0. So that's going to be 1.2 times 10. Now, here's my decimal point. Where is it originally? Originally, it's right there. So I have to go 1, 2, 3, 4, 5 places to the right. So that is times 10 to the 5th power. Okay? There is no homework for tonight. Enjoy the night off. If you still have homework or old things you need to get to me, please get those to me soon. I have to have grades entered in by Wednesday for this first quarter. Okay? Good job today. I know it's kind of rough the first day back, but I don't think this was too bad. And there's no homework, right? So there's that.